Arithmetic sequences and series. A sequence in which the difference between each term and its previous one remains constant is called an arithmetic sequence. This constant difference is called the common difference of the sequence. Investigation 10. 1. Which of these sequences are arithmetic sequences? For those that are arithmetic, what is the common difference in each case? Okay, so you go through these and you look for the ones that have the same difference between each term, either added or minus. It's got to be the same number. So you go through those. Why don't you stop the video and go through those and check which ones have a common difference. Now this common difference is denoted by a D, and we're going to look for that. So for example, the first one, it looks like it's 2. We're adding 2 to each term, and we have a series of numbers. Okay, if you come to this one here, adding 9, and then there's 90. So that's not arithmetic. Okay, you need to go through there and see if you can discover a common difference between each term. And if there is a common difference, it's an arithmetic sequence. 2. Write down A, the first 5 terms of a sequence in which the difference between each term and the previous term is always equal to 4. B, the first 5 terms of a sequence in which the common difference is equal to -3. C, the first 4 terms of an arithmetic sequence in which the first term is 2 and the common difference is -0.5. So you can do those 3. For example, the first one, 5 terms in which the common difference between each term and the previous term is always equal to 4. So we could say, for example, 10, 14, 18, 22, 26, 30. Not sure if that was 5, but that's what they want you to do here. Okay, this is important. Number 3, the sum of the terms of an arithmetic sequence is called an arithmetic series. A, which of these sums are arithmetic series? How can you tell? And then you've got them listed like that. Well, is there a common difference between these numbers? It looks like 6, 6, and 6. So that would be an arithmetic series. Okay, stop the video and think about these other ones here. Is there a common difference between these terms? B, write down an arithmetic series with 6 terms in which the first term is equal to 4 and the common difference is equal to 0.20. Okay. So the first term is 4. The second term is going to be 4.2. All right. And we've got 6 terms. So you've got to do 6 terms, and you've got to put plus, 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 and on the left you'll put S with a 6 underneath. You see there's S is a 5, you've got 5 terms. They've asked you for 6, so you're going to use S with a sub 6 there. 4, conceptual. How do you distinguish an arithmetic sequence or series from other sequences or series? Well, it's the common difference. That's a very important part of this, the D, the common difference. If it has a common difference between each term, it is an arithmetic sequence or series. Okay, here's some definitions. An arithmetic sequence with first term U, 1, and common difference D can be generated as shown. U1, well, U2 is obviously U1 plus D. U3 is U1 plus D, so that's U1 plus 2D. U4 is U1 plus D plus D plus D, and that's U1 plus 3D. And then U5 is U1 plus 4D. What would the expression be for U6? What do you notice about the number that multiplies D? Well, this number is going to be, that if that's n, we consider that n, right? That's the first term, the second term, the third term. So this number is n minus 1. Let's have a look. Following the pattern, un equals u1 plus n minus 1d. That's the pattern, and that's called the nth term of the arithmetic sequence. The general term or nth term of an arithmetic sequence with first term u1 and common difference d is u sub n equals u sub 1 plus n minus 1d, where n is an element of positive integers. Remember, n must be 1, 2, 3, 4, 5, 6, and so on. It must be an integer, a positive integer. Example 12, the first term of an arithmetic sequence is 5 and its common difference is 2 on 3. A, find the second and third terms. So that's here. There are the answers. How did we do it? Well, we know the first term is 5, and every new term is found by adding 2 on 3 to the previous term. So if you have to find the second and third terms, the second term is 5 plus 2 on 3, so that's 17 on 3. And the third term is 5 plus two of those, or they've just added, for U3, they've just added U2 plus the difference. Okay, let me just go through that again. The second term is the first term plus the D. The third term is the second term plus the D, and that's what they've done here. Or you could say the third term is the first term plus 2 of the D's to get 19 on 3, and that's why they've got that. B. Write down an expression for the nth term. Well, the nth term, this is our formula which we just looked at. It's un equals u1, that's the first term, plus n minus 1 times d. Substitute 5 for u1 and 2 on 3 for d in the formula for the general term, and we just saw that. C. Determine whether or not 49 on 3 is a term of this sequence. C. 49 on 3 is the 18th term. If 49 on 3 is a term of this sequence, then there will be an n for which un equals 49 on 3. Now that n would have to be an integer. So we put on the left-hand side here 5 plus n minus 1 times 2 on 3, because that's the first term. We're actually trying to, we've set up an equation where we have to find the unknown, which is n. Because we know u1, we know d, and they told us, is this a term? If it is a term, we're going to put it on the right-hand side of the equation. If we get an n that's an integer, it will be the term. So we resolve and we solve for n, and we find that n minus 1 equals 17, or n equals 18. That's a positive integer, therefore 49 on 3 is in the sequence. D. Find the first term of this sequence that is greater than 25. Okay, now they've found it as 205. Now you can set this up on the GDC, and we can do that in class. Also, there probably is a few videos on YouTube that show that. You set it up in a table, and then you just scroll down the table, and that's the quickest way to find it, really, because you can set up a sequence in tables in the Inspire. Example 13, consider the finite arithmetic sequence minus 5, 5, ... and 1,189. If it's finite, it means it ends here. A, write down the common difference D. Okay, we've got enough information here because they told us it's arithmetic. Okay, so we just have a look at the difference. Now, the way that you find the difference is actually D equals U2 minus U1. Okay, so if we do that, D equals 8. U2 is 5 minus U1, that's minus a minus, is a plus, so it's 8. Now, here it is here. The common difference is the difference between any two consecutive terms. D equals 5 minus 3, and that equals 8. So remember, the difference equals U2 minus U1, or U3 minus U2. In fact, if they hadn't told us it's an arithmetic sequence, you would have to set up a U2 minus U1 should equal U3 minus U2. B, find the number of terms in the sequence. Okay, they've told us this is a finite arithmetic sequence. We have to find out the number of terms, and the answer was n equals 150. Method 1, the general term of this sequence is, remember, this is our formula, un equals u1 plus n minus 1 times d. We know what d is. We know what u1 is. We can find n there. We also know that un equals 1189. Okay, so if we put that, we equate this to that, we can again find n, as we just did in the previous example. Use your GDC to solve for n, or you can just do it by sums, but you could use the calculator, I guess. Okay, and then you solve it for n, and then you get 150. Method 2, use the GDC to create a table of all the terms, and then scroll down until you see the value 1189. However, this may take you longer than method 1 when the value of n is big, as in this example. Okay, well, it's possible. That's right, because you'd have to scroll down a long way. But there is a way to put a sequence in the table function of the Inspire, and no doubt the 84. Exercise 5J, 1. Okay, questions like find the value of the common difference. We can find that, right? If you know, what have they got? The first term is minus 10 and the seventh term is minus 1. Find the value of the common difference. Now, how would you do that? Well, we know that the seventh term, that's u sub 7, equals, this is the first term, right? Minus 10 plus 7 minus 1 times d. You could find it like that. Go back and have a look at the formula, and always keep in mind, they've already told us it's arithmetic sequence, So we know that the 7th term is actually the first term plus 6 times d. You know that as well, which is actually the formula. Find the 15th term of this sequence. Okay, number 2, the nth term of a sequence is defined by that. Find the values of B1, B2, and B3. Well, it's just substituting. If you put a 1 there, you put a 1 there, you put a 1 there, and you find B1. Show that this sequence is not arithmetic. To show it's not arithmetic, the difference between the terms must be different. It won't be constant. 3, the first terms of an arithmetic sequence are 5, 9, 13, and 17. They told us it's arithmetic, so we're expecting the same difference. That's 4, 4, and 4. So it looks like it is. A, write down the general term for this sequence. Well, the difference is 4. The first term is 5. So UN equals 5 plus n minus 1 times d, which is 4. So the general term is going to be 5 plus 4 times n minus 1. B, determine whether or not 116 is a term in this sequence. We'll have a look at the first example and have a look at part C. It's a similar type of question. 4, in an arithmetic sequence, we know the term 3, we know the term 10, the common difference is D. Write down 2 equations in U1 and D to show this information. This is very, very good to do. It's good practice for the tests. Okay, we know the formula for U3. U3 is going to be U1. They want it in terms of U1 and D. So U3 would equal U1 plus n minus 1D. So that's 1, and U3 is 12. So 12 equals U1 plus 3 minus 1D, which is 2D. So we can write down that 12 equals U1 plus 2D. That would be one of them, and then you have to find another one using this one. Then we've got 2 unknowns, and we've got 2 equations from A, so we can find out that. If we've got 2 unknowns in 2 equations, we can find them, either through substitution or by elimination. And then find the 100th term. Well, once you know U1 and D, you've got the nth formula. UN is U1 plus n minus 1D, so we could easily find the 100th term. 5, when a company first started, it had 85 employees. It was decided to increase the number of employees by 10 at the beginning of each year. Find the number of employees during the second year and during the third year. Well, if it started with 85 and it adds 10 every year, 10 is the D. So we know that in the second year it's going to be 95, and in the third year it's going to be 105. How many employees will this company have during the 10th year? Well, you could just write a whole long line of numbers added together, as some students actually do in the final test. Anyway, but what you want to do is go back to the nth term formula. We have enough. We know the first term. We know the common difference. So we know that the nth term equals 85 plus n minus 1 times 10. So that's 85 plus 10 times n minus 1. And of course, you can expand that out. Okay, let me just write it here. We've got U1 is 85. They told us that. U2 is 10 plus. So that's 95. And then U3 is another 10 on 95 is 105. We know the nth term formula is U1 plus n minus 1D. So that's 85 plus n minus 1 times 10. And that leads us to 85 plus 10n minus 10 because I've expanded that, which is 75 plus 10n. Okay, we know that's right because if you put a 1 there, it's going to be 85. When you make n equals 2, it's going to be 95. And you put n equals 3, it's going to be 105. And that's what we expected. So if we wanted to know for the 10th year, we just put U sub 10 equals 75 plus 10 times 10, and that's 175. So B is easy now because we've got the nth term formula here, which is UN equals 75 plus 10n. So you just substitute 10 in, right? So that's easy. C, after how many years will the company have 285 employees? Well, we can use the nth term formula that we have here, and we just say that the left-hand side, which is this term, 285, equals 75 plus 10n, and we solve for n, and that'll give us the number of years. Now, it does say we'll have 285 employees. If, for example, n, that when you solve this, n was, for example, 20.2, you'd have to choose 21. You couldn't choose 20. You have to go to the nearest integer that makes sense for in the context of the question. Question 6, 7, and 8. Question 9, question 10, and question 11.